I'm going to start this video by looking at number 36 in the textbook. So number 36 says, use the given values to set up a table to evaluate the limits and round your solutions to 8 decimal places. Okay, so every time I do this to myself, every time I forget. We look at 38, rounding to 8 digits, 36. We're looking at the limit as x approaches 0 of sine of the sine of 3x over x. And we're looking at, we need it rounded to 8 decimal places. All right, so we'll just copy down the tables from the left. And from the right. They wanted us to look at negative 0.1, negative 0.01, negative 0.0001, and negative 0.0001. We do the same thing for the left as for the right. Again, this is actually going to be another even function, just like the one we did in the other video. So once we do one side, we're going to have the other one. Sine of 3 times x divided by x. Let's go on to Desmos, which knows how to behave. Go the sine of 3 times some x divided by that x. We're going to get 2.9552. It wanted 8 decimal places, so 0207. And then change the negative 0.1 to negative 0.01. 2.9996. No, 2.9995. We're not rounding yet. 5002. Add another 0. That's all we're doing here. 2.9999. 995, and this one doesn't actually give us the 8th decimal place for some reason. And let's add another 0. 2.99999996. So what do we think is happening from the left? As we get close to 0 from the left, it really looks like this function's going to positive 3. And you can do the same thing from the right. Again, it's an even function. So from the right, you're going to get the exact same function values. It's also here. This one's also here. And so on. It should be the same. All right. And then the book also tells you nope, that's all it wants us to do. And then there's a cool little answer in 37 about something we're going to talk about later. All right, let's do 44 next. All right, it's, yeah, for some reason pressing Alt. It's like confusing. Or is it like pressing Tab? I don't know. Either Alt or Tab is doing something. Anyway, let's look at number 44. I'm losing my mind, everyone. I'm sorry. All right. In the following exercises, set up a table of values in around 8 significant digits. Make a guess about what the limit is. Graph it. Determine a limit. Was the conjecture correct? The limit as theta goes to 0 of pi divided by 0. All right, let's do this. One of those days, everyone. It's one of those days. The limit as x goes to 0 of pi divided by x. Oh, it's theta. Not a big difference, but it is a difference. Use the variables that you were given. So we should know a little bit about what to expect here based on the example from the videos, but I don't want to spoil it. All right. So let's look at theta approaching 0 from the left. And what's the function value at theta? Let's do the same thing from the right. And again, we're going to look at negative 0.1, negative 0.01, negative 0.001, negative 0.0001. Now do the same thing for the positives. Pi divided by theta. Let's use a calculator. Wherever my calculator is. All right, so sine of pi divided by theta. So, all right, it's equal to hold on, give me 1 second. I want to reread the instructions and make sure I'm doing this right. I don't want to, because there's something actually happening here as part of this example. Okay, all right, I don't want to spoil it for you. We're doing it correct. We're doing it correctly. All right, it's going to equal 0. I like this problem. All right, let's look at pi divided by theta for 0.00. Add another 0. Add another 0. This one's just rounding error. That's basically 0. Doesn't matter how many zeros. It's all rounding to something that's 0. So all of these, the function value is 0. Oh, okay. And this is an example of an odd function. So I already know. Oops. So this is an odd function. Wait, is it an odd function or even? Maybe I don't know. Yes, it's an odd function. But it doesn't turn out to matter whether it's odd or even as long as it is 1. You evaluate to the positives, you're also going to get, and I'll show you, right? You're also just going to get a bunch of zeros. So our conjecture is that the limit is equal to 0. Read the instructions. Round to 8 significant digits based on the table. Make a guess about what the limit is. And graph the function to find the limit. Pi divided by 0. Let's graph it. Y equals pi divided by theta. All right, maybe it wants an equal sign here. That makes sense. Yeah, we got this. We got this again. So remember, this is the situation from the video. This limit, as theta approaches 0, it doesn't exist because the function just keeps oscillating. So what's going on? The limit doesn't exist. This conjecture, our guess, the guess that we made from our table is wrong. Guess was wrong. Why? Oh, I forgot my sign here. We're looking at the sign of this. Let's look at our function. Let's look at what's happening. Remember your trig. Let's do these algebraically. What's the sign of pi divided by 0.1? Well, dividing by 1/10 is the same as multiplying by 10. This is the sine of 10 pi. Sine is periodic. Sine of 10 pi is the same as sine of 8 pi, has a period of 2 pi. This is actually the same as the sine of 0, and it is equal to 0. Right? And sine of pi divided by 0.01, right? That's the sine of 100 pi. It's still like it's 2 pi periodic. So we're still oscillating. We're oscillating just like the graph said we're oscillating, but all of these points that we're choosing just happen to be points that we're going through 0. So we're kind of cherry picking accidentally. And in fact, if you made another table, right? What if we made a table of like negative 0.2, negative 0.02, negative 0.002? What would happen to the function values if we use 2's everywhere? Sine of pi divided by negative 0.2. All right, that was a bad choice. It's the same thing happening. That was a bad choice. Let's say negative 22 or something, and then 022, and then 022, and then 022. Now it's oscillating between a number that's close to 1 and close to negative 1. So if we chose this one, we could see that the limit doesn't exist. So you have to be a little careful. We're not proving anything in this section. Remember what this section's called. Intuitive. I don't remember what that section's called. But one of the parts is intuitive definitions of limits. Okay, so this is no proof. In the next video, we're talking about limit laws. And that's when we're going to actually be able to start proving things about limits. But in this one, we're just trying to experiment. All right, I have 5 minutes before student hours are supposed to start. I have one more problem I want to do for you guys. We can do a problem in 5 minutes. All right, 76. Look at 76, and I'm not going to sketch a graph of a function with the given properties. The limit as x approaches 2 is 1. We need this property. Ooh, it didn't freak out. As it approaches 4 from the left, it's 3. And as x approaches 4 from the right, it's 6. And finally, it tells us that f of 4 is not defined. So again, it just wants us, here, let me double check. It just wants to sketch a graph. So there's infinitely many options for things that you could use to answer this question. Just wants you to show that you can understand how to do these things. So again, what are the important points? X equals positive 2 is important. And x equals positive 4 is something that's also important. All right, I'll make a blue graph. So the limit as x approaches positive 2 is 1. All right, now it didn't tell us anything about f of positive 2 or f of 2. So we can actually just have the limit equal the function value. We can actually have just this point here. But at f of 4 is not defined. From the left of 4, it has to be 3. From the right of 4, it has to be 6. So it could look like a piecewise function that kind of looks like this. This satisfies every definition. The limit as x approaches 2 is positive 1, check. 4 from the left, positive 3, check. 4 from the right, positive 6, check. f of 4 not defined, check. That's everything we need. But again, there's a bunch of different functions that you could do with these properties. You could do this. Oh wait, no, you couldn't do that. The limit has to... You could have this be like an open hole. Again, there's a bunch of different answers. You could have this. There's a bunch of different things that you can do. You could have this. Still true. All right. So you can play with this a little bit. Play with these. You're going to have a lot of different answers. The book is going to have like a sample answer, but if you want to know whether your answer is right, that's a great question that you can ask me. Okay. And I'd be more than willing to talk to you about that. Anyway, it's student hours time. So hopefully this helps you on your homework, and have a great day.